In this video, we will discuss how do we differentiate the sum or difference of two functions, two differentiable functions, right? So their sum, their difference should be differentiable. So let's start from the setup, right? So we assume f and g here are differentiable functions, differentiable. I can generate two new functions. One is sum, the other one difference, right? So we get f of x plus g of x, right? That's a new function. We want to see whether this function is differentiable, right? So what you want to do is let's write down a evaluation of this, right? Later we just apply our formula. So this is equal to, again here, if you don't have any uh, rules yet, apply our definition. Right? This is same as what? F of x plus h plus g of x plus h minus f of x plus g of x over h. Right? By our assumption, f prime, g prime exist. Right? And we know the definition of f prime, g prime. That's two limits, right? If you try to look at the limit we want to evaluate, we know this, combine this with this, combine f together and combine g together. That's basically where the f prime g prime come from, right? So this is same as h goes to 0, f of x plus h minus f of x over h, then plus g of x plus h minus g of x over h. We can split it into two terms, right? Just do a distribution, right? Split it and do a distribution here, right? Now we know that the first term here, and because both limit exist as finite numbers, we can evaluate the limit like separately, right? If you evaluate the limit separately, you get, so that's basically using the limit laws. So this is basically get f prime of x plus g prime of x. So sum is a good operation. If you differentiate a sum, you just differentiate term by term. The answer is the duality of the sum of the function, right? And very similar, you can get the difference if you want to differentiate the difference of two differentiable functions. You get the difference of their derivatives, right? Not much difference. You can use the same formula, just to do a small modification in a few times, in a few places, right? So we get our sum and difference rules. And the first one here is f plus g prime is f prime plus g prime. And f minus g prime is f prime minus g prime, right? So that's our two new rules, and together with our constant multiple rule, which is c f prime is c dot f prime, right? So let's try to see one example. Example here to apply this rules, right? We are given a function y equal to x cubed plus 4x to 1 over 4 minus 2 over 2 times fourth root of x. So we want to differentiate this function, differentiate this function here, right? Now you can see that this is a quotient. We don't have quotient rule yet, right? So we need to split it, do a distribution here, and change it to sum or difference or non constant multiples, right? one more rule we should know that is x to a prime is the duality of power function, right? So we want to simplify our function first, and then apply our sum difference rules, right? So y here equal to, because we don't like quotient, so we just split it. You get x cubed over 2 times fourth root of x plus 4 times x to 1 over 4 over fourth root of x times 2, and minus 2 over 2 times fourth root of x, right? We know that fourth root of x is nothing but x to 1 over 4, right? So this is equal to 1/2 x to 3 minus 1 over 4 plus 2 times x to 0, and we know that x to 0 is 1, minus 1 times x to negative 1 over 4, right? So we have a sum or difference of constant function, power function with a multiple, right? And so this is equal to 1 over 2 x to 11 over 4 plus 2 minus x to negative 1 over 4. Now we can apply our sum and difference rules, right? And the constant multiple rules. And so this is equal y prime. We are ready to use our rules. Y prime here is 1/2. That's a constant multiple, and keep it there, time the duality of the first term, which is 11 over 4 times x to 11 over 4 minus 1, right? The duality of 2 is 0 because that's a constant, right? Minus negative 1 over 4 times x to negative 1 over 4 minus 1, right? So this is equal to 11 over 8 x to 7 over 4, then plus 1 over 4 x to negative 5 over 2, 5 over 4. Right? That's how do we differentiate this function here. And let's discuss one more duality here, right? How do we differentiate exponential functions? Exponential functions. And let's say that f of x is e to x, right? We want to differentiate this function, right? And recall that we have a definition of e, right? When we discuss e, we have a definition. Definition of e here is what? Let me try to sketch a graph here. Is the number at which the duality of the tangent line to this exponential function is 1 at this point, right? At this point, the tangent line, the slope of the tangent line is 1, right? And by our discussion of the tangent line, the slope is nothing but the difference of y value over the difference of x value, and make that difference of x value getting closer and closer to 0, right? So if you use that, this is e here is defined such that as h goes 0, e to h minus 1 over h minus 0, because x value is 0. So that this is a slope, right? This should be 1. So this is basically in terms of limit, how do we define the number e? So that's a unique number such that this limit is 1, right? Now let's try to develop the duality of this function. So f prime of x equal to the limit as h goes 0, f of x plus h minus f of x over h, right? As our definition, we don't have any other rules to use. So this is as h goes 0, e to x plus h minus e to x over h here, right? And so this is equal to as h goes 0, this we know that e to x plus h is same as e to x times e to h. So the first term and second term has a common factor, which is e to x. So e to x, e to h minus 1 over h. I can see that h here is changing, but x is not changing, right? So as h goes 0, that e to x doesn't change at all. So this is a constant. E to x is a constant compared to this limit, right? So we get this is e to x times 1, which is e to x. So we get our the duality of exponential functions, which is e to x prime is e to x. So this is how do we develop the formula, the rule, the formula for the duality of exponential function.